no F is O. How do you draw this? No F is O. So draw F and draw O, and no F is O. So these two cannot touch each other, right? F and O cannot touch each other. All O are C. All the O are C. All O are C. And all C are M. All C are M. Right? Okay. So this is the diagram. Yeah. No F is O. All O are C. All C are M. And there is one more statement. No M is D. No M is D. So let me draw D here. And no M is D. So M and D cannot overlap. See, the reason I'm putting two tick cross marks here is to give you a clarity that D and M cannot overlap, because both of them have got two cross marks. But D can go and touch F, because F has got only one single cross, D has got two crosses. I'm sure you would understand this better after having gone through the video, syllogisms video, but you should be clear with this fundas, right? So no F is O, these two cannot touch each other. All O are C, and then all C are M, and then no M is D. No M is D, right? So M and D cannot touch each other. Now look at the conclusions. The first one here. No C are F. No C are F. No C are F. Is it true? Well, if you look at the basic diagram, it is true. No C are F. C and F cannot touch each other, right? Look at the basic diagram. No C are F. No C are F. So when you take the basic diagram, yes, it is true. It is true. No C R F is true. But will it always be true? Just think about that. Basic diagram, yes. Here's the basic diagram. And according to the basic diagram, no C R F is true, because C and F do not touch each other. But like I've told you, when a conclusion satisfies the basic diagram, you have to verify the other possible diagrams as well, right? And a simple understanding here is that, see, F cannot touch O. But in possible diagrams, we can, make F overlap with C and M. We can make F overlap with C and M. For example, for an instance, let's assume that we draw F in this way. F. Okay, I think it is just touching O there. So let me redraw it so that we don't get confused. Let's say this is the diagram for F. And here's the diagram for O, like we had seen earlier. Right? So this green diagram that you see is a possibility case. What we have drawn in purple there is the real case, real basic diagram, but this is a possible diagram. Now the moment you draw F in this fashion, what happens? You find that F and C overlap. You see there's an overlapping between F and C. There's an overlapping between F and C. And even without drawing this basic possible diagram in what we have drawn in green color, you would know that F will not touch O, but F can come and touch C, F can come and touch M, etc. Right? So no C or F, though it satisfies the basic diagram, it should be taken as a wrong conclusion, right? It should be taken as a wrong conclusion because it fails in the possible diagram. No C or F fails in the possible diagram. Next one, some F are D, some F are D. Now, now you have to forget about this green colored F, because that was drawn as a special case. Look at the original F, right? It says no F R D, no F R D, right? Forget about all this. No F R D. Compare F with D. What do you find? Some FRD. The conclusion is some FRD. As per the basic diagram, F and D do not overlap at all, right? F and D do not overlap at all. So can we say some FRD? No. In the basic diagram itself, it fails. Some FRD fails in the basic diagram itself. Hence, some FRD is wrong. So neither conclusion 1 nor conclusion 2 follows. None follows. None follows. So your answer should be option 4. None of these. Sorry, option should be option 4. None follows. Answer should be option 4, none follows. Remember, do not consider option 3 and option 4 to be the same. Though they look to be similar, there is a huge difference between option 3 and option 4. Option 3 says none of these. When will you mark this as the answer? Only when 1, 2 and 3 are wrong. Sorry, 1, 2 and 4 are wrong. Only when conclusion 1, conclusion 2 and conclusion 4, these 3 are wrong. In that case, you will mark none of these as the answer. But here conclusion 4 is correct. None follows is correct. You're able to follow. None follows means none of these conclusions follow. None of these means none of these options are correct. Okay, none of these always refers to the options. This refers to the options. None of these options are correct. This refers to the conclusions. Right? When you say none follows, this refers to the conclusions. So none of these conclusions follow. Option 4 would be the answer. All bottles are caps. Some caps are covers. No bowl is a cover. So draw the diagram for this. All bottles are caps. All bottles are caps. some caps are covers, some caps are covers. So I think we will use CP and CV, right? Because both these start with C, right? So let's not confuse ourselves. So all bottles are caps, some caps are covers, and no bowl is a cover. No bowl is a cover. So no bowl is a cover. Again, let's say this is BT and BW. Okay. So that's the basic diagram. Basic diagram for the given statements. All bottles are caps, some caps are covers, and no bowl is a cover. What did we ensure here? We have ensured minimum overlapping, right? Least encroachment of different sets here, right? All bottles are covers anyway, has to be done this way. But when you say some caps are covers, try to draw covers in a way that it overlaps only with caps, right? Try avoiding overlapping with bottles there. And then no bowl is a cover. So no bowl is a cover can be drawn in this way. Now, of course, you can draw bowls on this side as well. But like I said, basic diagram should have minimum overlapping. So we'll avoid doing that. Okay, so try to keep it as disjoint as possible, right? Now look at the conclusions. The first one, at least some bottles are covers. At least some bottles are covers. Now we have discussed this a number of times that at least some and some both mean the same, right? At least some is as good as some. So don't get confused when you see at least being used in conclusions, right? At least some is as good as some. So what do we say? Some bottles are covers. The conclusion says some bottles are covers. Now, do you really see that? No. When we look at the basic diagram, you find that no bottle is a cover. There's no overlapping between bottles and covers at all. So, can we say some bottles are covers? No. This is wrong. Conclusion number 1 is wrong. Look at conclusion 2. No cover is a bowl. No cover is a bowl? Yes. This is definitely true. You don't even have to look at the diagram for this one because the statement was no bowl is a cover. And the conclusion is no cover is a bowl. We very well know that for no A is B, the definite conclusion is no B is A. Right? No A is B. What's the definite conclusion? No B is A. No B is A. So if he says no bowl is a cover, definitely no cover is a bowl without even worrying about the diagram there. So conclusion 2 definitely follows. Look at conclusion 3. All caps are bowls. All caps are bowls. Now do you see this? All caps are bowls? No. All caps are bowls. Not possible. From the basic diagram itself, you find that caps and bowls do not even touch. Right? Caps is here and then here are bowls. There's no overlapping between caps and bowls. So this particular conclusion, all caps are bowls, fails in the basic diagram itself. And what's the thumb rule? If a conclusion does not follow the basic diagram, you can treat it as false, right? If a conclusion does not follow the basic diagram, it is definitely false. If it follows the basic diagram, then you'll have to worry about the possible diagrams there. Okay. So I think very clearly the answer is only 2 follows. Only conclusion 2 follows.